Okay, so now let us see a case of a uniform beam. I'm done with the solution because it was going to be lengthened. So let us go through the solution here. An uniform beam AB 4.5 meters long is balanced on two supports P and Q, so that AP is this and QB is that. When the mass of 20 kilograms is pressed at either end, the beam is at the point of toppling. Toppling means the point is about to move off where it's being pressed. And then non-uniform means that the weight of that rod is not in the middle. As simple as that. Find distance from A at which the weight of the beam acts. Then part B, weight of the beam. Part C, distance from A at which the 20 kilogram mass must be pressed for the reaction to be of the support to be equal. So what we are going to do, we say, let W be the weight of the beam acting at a distance x from A. So if from here up here is going to be our, or how this is our support P, this is our support Q. And then that's that AP is 0.4, so meaning from here up here is 0.4. Then QB is going to be 0.8, so that's why we have 0.8. So for any support, for any contact between this beam and this, there is a reaction at Q. Then also here there's a reaction at B. Then we say that weight B x meters from A. So from here up to here we have x. Means that if this is 0.4, it means that this is going to be x minus 0.4. As simple as that. So now, if we told us that at either ends where I put this 20 kilogram mass, this toppling is going to happen. So that's first consider when you're putting it at point A. When you put at point A and dissolve vertically, it means that this RP and RQ are going to be equal at equilibrium. So these vertical forces are equal to these downward forces here. Now, at the point of toppling, RQ is 0. This contact is, this reaction here, this contact is 0. Why? Because if I'm having this, at the point of toppling, we assume that there's no contact there at the point of toppling there. Before that happens, there's no contact. So meaning, this reaction is going to be 0 at the point of toppling. And when RQ is 0, we put it here, we have that. So let us now take moments about A. Take moments about A so that I can easily get what RP is. Take moments at A. This is going to be 20 times 0 because there's no parameter distance there. Then I have my RP. The parameter distance from A is 0.4 as is there. Equaling to W for it is going this side. So I have W then times the parameter distance from A. Because we say the principle of moment says the sum of clockwise moments is equal to the sum of anti-clockwise moments. That's what we have. So you see if we divide this side, we have this when we simplify. 0.4 is the same as 2 over 5. When you multiply this side, you get 5 over 2. And this is the equation 2. But you can see that this one is equal to that. But we are going to see that at that case. Next case. Now, when I put the program mass at B, now when I put it at B here, the idea is the same, this one is remain the same, but the reactions are going to be different. Why? Because this first one is acting this side. The reaction here is going to be different, and even here is going to be different. That's why I'm putting prime. Now, if from here up here is x, it means that from here up here is going to be 4.5 minus x, because the wall is 4.5. Okay, resolving upwards, this plus this is going to be equal to this plus this. At the point of toppling, RP prime is going to be 0. When now this weight is acting this side, at the point of toppling, when this one is almost getting off, it's going to be 0. Putting it here, we have that's equation 3. Now take moments at B, that we are going to be having now, W, this W is going in that side of anti-clockwise from here, from B here. It's going this side, so we have W, its perpendicular distance from B is this from here. Then times from here, this one is going, for it is going clockwise. I have this times this. This is the perpendicular distance of this force. there. This one is at the point where I take moments from, so its moment is going to be 0. So when time is 0, this is time is 0. We have it vanishing. Making this the subject, we have this is 6 over 10, and the cos of pi beside we have 10 over 6. RQ is equal to that. You know that this R applying Q is equal to this. So when you bring this and you put it here, you know that. You also know that 1 is equal to RP is equal to RP. Still that way times 20, plus 20B is equal to that. So you know that if this is equal to this and this is equal to this, it implies that this is equal to this. When I equate them, see that by 5, 2, by 2, 1, by 2, 3. So we start remaining with x, which will be 2 over 3. When you multiply this, you get 3x. This 2 times this will get 9. This 2 times this will get 2. When I bring this side, I have 5x equal to 9, so my x will be 1.8 meters. Now if we have x, we can either use this or this to get W. So when I use this, so that my x is 1.8, this is W. When I get this is going to be this times this, we get 4.5. When I take this side, I'll be subtracting off W. I'll be remaining with 3.5 equaling to this, and when I substitute, I get my W as 6. Then part C, they are telling us that the distance from A at which the 20 kilogram mass must be pressed for the reaction of the support to be equal. So that I said, let 20 kilograms be pressed at a distance y from A. Now here, this is our distance y from A. I think you can see y from A. So this is where we are placing our 20 kilogram mass. Now here, be careful. This is 0.4. This is 0.6. Remember the whole is 4.5. So when we get this plus this, we get 1. 1 minus 4.5, we get now this. So meaning from here up to here is 3.5. Or from here up to here is 2.1. Okay. Now, when I come also to this, you see that now, if from here up to here is y, and you know that from here up to here is 1.8, add this to get 1.8. Implies that this distance only is y minus 1.8. But now I need that there. So let us resolve vertically. Resolving vertically here, we have this. These are equal now because we are putting this way so that the reactions at P and Q are equal. That's why this one is R and this one is R. So in resolve vertically, this plus this is equal to this first plus this. Remember, this is now our weight. We got as this. So 2R, when I divide there, I get 0R as 126. Now take the moments at P. You can able to see that take moments at P and clockwise is that now. And clockwise R, the calculated distance from here to here is 3.5. Then equaling to, these ones now are going clockwise. So it means that the sum of the anti-clockwise moment is equal to the sum of the anti-clockwise, and then the sum of the clockwise moment. That's why I'm having this. The calculated distance from here is 1.4, then plus this 20. Now, the calculated distance from here up to here, we get this minus this. I think you can see that. So here it's going to be just y minus 1.4. We add this plus this. When you add this plus this, we'll be getting the distance from here up to here, which is 0.4. When you add this to this, you see you have a negative 1.8 plus 1.4, you get 0.4. When you add this plus this, will be having that. So that's why we have this b, then times that calculate the distance from there. So to simplify this r, we have b minus 9.8, and the substitute, you see our y is going to be 2.25. So that's the distance where that 20 kilogram mass must be pressed, such that the reactions are the same. So that's it, members. I wish you well.